Scientists want to bring back these extinct animals. Using ancient DNA fragments, cutting-edge gene editing, and a whole lot of scientific courage, researchers around the world are working to resurrect animals that disappeared years, centuries, or even millennia ago. And guess what? It's already happening. Join us as we find out which animals are going to be resurrected. Trust us, this video will shock you. Let's go. Number 10. Cave lion. The cave lion dominated vast regions of Europe, Asia, and parts of Alaska during the Ice Age. Slightly larger and more robust than modern lions, these impressive predators were adapted to survive in cold climates. Despite their name, they didn't actually live in caves. That's just where their best preserved fossils were found, giving the species its name. Like the woolly mammoth, cave lions left behind valuable genetic material. Several cubs frozen in Siberian permafrost have been discovered with soft tissue, fur, and even internal organs preserved. This excellent preservation dramatically increases the chances of recovering high-quality ancient DNA, a fundamental step in any de-extinction attempt. Better DNA samples mean more accurate genetic reconstruction, another factor working in the cave lion's favor. It has a very close living relative, the modern lion, Panthera leo. Some scientists even classify the cave lion as an extinct subspecies of today's lion rather than a separate species. Number 9. Smileodon. Among all extinct Ice Age predators, few capture the imagination like Smileodon, better known as the saber-toothed tiger. With its massive canine teeth, imposing appearance, and powerfully built body, it became an icon of prehistoric power and ferocity, despite disappearing over 10,000 years ago. Despite its nickname, Smileodon wasn't actually a tiger. While it belonged to the Felidae family, cats, it was part of an extinct subfamily called Machairodontinae, completely separate from modern felines like lions, tigers, and domestic cats, which belong to the Felinae subfamily. This evolutionary distance creates a massive problem for de-extinction efforts. While mammoths have Asian elephants and dodos have Nicobar pigeons as close living relatives, the saber-toothed tiger has no compatible modern equivalent. Current de-extinction methods rely heavily on editing the genome of a closely related living species and using that species as a surrogate mother. Without a suitable relative, this approach becomes nearly impossible. Nevertheless, the idea of reviving Smileodon continues to fascinate scientists and research labs as a long-term challenge. It's frequently mentioned in discussions about de-extinction's future, not just because of its popularity, but because of what its revival would represent technologically. For now, bringing back the saber-toothed cat remains in the realm of scientific ambition rather than practical reality. But if it ever happens, it would represent one of biotechnology's greatest achievements. Number 8. Woolly mammoth. Perhaps Colossal Bioscience's most famous project involves reviving the woolly mammoth, those massive, shaggy relatives of modern elephants that roamed the frozen steppes of the northern hemisphere during the last ice age. Standing up to 13 feet tall and weighing more than 6 tons, these giants sported curved tusks and thick fur coats that helped them survive extreme cold. Although they disappeared about 4,000 years ago, with the last populations hanging on in isolated Arctic islands. Woolly mammoths left behind an unusual scientific treasure, perfectly preserved specimens frozen in ice. Unlike most fossils, which are just mineralized bones, frozen mammoths have been found with hair, soft tissue, and even stomach contents intact, some looking like they simply fell asleep in the ice. The famous baby mammoth named Lyuba was discovered in Siberia with her brain, muscles, and even spinal cord preserved. But resurrecting the mammoth poses challenges far greater than the Direwolf project. While scientists successfully modified modern wolf DNA for the direwolf, no complete mammoth genome exists. Ice-preserved DNA is fragmented and degraded, like trying to solve a puzzle with half the pieces missing and the rest badly damaged. The solution? Using the Asian elephant, the mammoth's closest living relative, as both a genetic template and surrogate mother. Colossal's team is working to insert genes for mammoth traits, thick fur, subcutaneous fat, and cold resistance, into elephant DNA. The result won't be a pure mammoth like those that once roamed the frozen plains, but a genetic hybrid, an elephant adapted for cold climates with mammoth-like features and functions. Why bother? Scientists argue that bringing back mammoths could help restore the Siberian tundra ecosystem, combat soil degradation, potentially help control carbon emissions, and represent a massive leap forward in biotechnology. Their optimistic projection. The first mammophant could be born by 2030, within our lifetime. I have a question for you. First, I would like to say that it is possible to follow the greatest curiosities of our world every day. But to do so, you need to be subscribed to our channel. So, are you already subscribed? If not, take the opportunity to subscribe now. Also, take the opportunity to like the video, so YouTube will recommend more videos from our channel. So, leave your like right now. And now that you have done that, let's go. Number 7. Woolly rhinoceros. Like the woolly mammoth, the woolly rhinoceros stands as one of the most iconic symbols of Ice Age megafauna. These massive herbivores inhabited vast regions of Europe and Asia, perfectly adapted to survive the harsh Pleistocene environments. Weighing more than 2 tons and sporting an impressive pair of horns, woolly rhinos shared their world with Neanderthals, mammoths, and other large extinct herbivores until they vanished around 10,000 years ago, likely due to a combination of climate change and human hunting pressure. Today, the woolly rhinoceros ranks among the strongest candidates for de-extinction for several reasons. First, their fossils are among the best preserved specimens ever found in Arctic permafrost. Many examples, including those with intact soft tissues, fur, and internal organs, have been discovered in Siberia, providing invaluable genetic material for scientists. Additionally, the complete genome of the woolly rhinoceros has been sequenced to high quality, a critical foundation for any de-extinction attempt. Genetic comparison with modern rhino species is already underway, particularly with the Sumatran rhino, considered the closest living relative to the extinct woolly species. Number 6. Tasmanian tiger. The Tasmanian tiger, thylacine, represents one of the most tragic recent extinctions. Despite its name, it wasn't a tiger or even a cat. It was a carnivorous marsupial native to Australia, Tasmania, and New Guinea. With a dog-like body and distinctive stripes across its back, hence the tiger nickname, the thylacine was an apex predator in these ecosystems for thousands of years. The arrival of European settlers in the 19th century spelled disaster for the species. Mass hunting, fueled by bounties offered by the government, habitat destruction, and introduced competitors like dogs and foxes pushed the thylacine to the brink. The last known specimen died in 1936 at Hobart Zoo in Tasmania. Since then, unconfirmed sightings have occasionally made headlines, but none have been scientifically verified. Nearly 90 years after its disappearance, the Tasmanian tiger may be closer to making a comeback. A partnership between Colossal Biosciences and the University of Melbourne's TIGRR lab, Thylacine Integrated Genomic Restoration Research, is leading the de-extinction effort. Their approach involves reconstructing the complete thylacine genome using preserved DNA samples and using the fat-tailed dunnart, a small living marsupial, as both a genetic template and potential host for the edited embryo. Number 5. Direwolf. The direwolf is back. Yes, you read that right. This prehistoric predator that vanished over 10,000 years ago has officially become the first extinct animal successfully revived through genetic engineering. The direwolf wasn't just an oversized version of today's wolves. Standing taller and weighing up to 150 pounds, these were apex predators with bone-crushing jaws and muscular builds that made them perfect hunters of North American megafauna. They chased down bison, wild horses, and other large prey across the continent for hundreds of thousands of years before climate change and the disappearance of their food sources drove them to extinction. After thousands of years of silence, Colossal Biosciences has announced they've brought back something remarkably close to the original dire wolf. Their approach didn't involve recreating the complete DNA of Enochian dirus, the dire wolf's scientific name, but instead genetically modifying modern wolf DNA. Scientists altered about 20 regions of the genome, focusing on the distinctive features of the extinct species: larger body size, modified shoulder and head structure, stronger jaws, bigger teeth, more powerful legs, and even distinctive vocalizations. Number 4. Dodo. The dodo remains one of the most famous examples of human-caused extinction. Native only to the island of Mauritius in the Indian Ocean, this flightless bird disappeared completely by the late 17th century, just decades after European colonizers arrived. Large, awkward, and unable to fly, dodos became easy targets for hunters and introduced predators like rats, pigs, and monkeys. Their extinction happened so rapidly, less than 100 years after Europeans discovered them, that the phrase "dead" as a dodo became synonymous with something completely gone forever. But what seemed like a permanent end might actually be reversible. Colossal Biosciences is leading a project to bring back the dodo too. Like their other projects, the plan isn't to magically extract complete, undamaged DNA. Instead, they're using gene editing on the dodo's closest living relative, the Nicobar pigeon, a colorful bird native to islands in Southeast Asia. The process involves comparing the reconstructed dodo genome from preserved museum samples with the Nicobar pigeon's DNA. Scientists will identify the key differences between the two species and edit the pigeon's genome to incorporate dodo characteristics: larger body size, loss of flight capability, distinctive bone structure, and unique plumage patterns. If successful, they'll place the modified embryo in a viable egg for development, aiming to produce a bird functionally similar to the dodo that disappeared over 300 years ago. Number 3. Passenger pigeon. For centuries, passenger pigeons were among the most abundant birds on Earth. Early 19th century estimates suggest billions darkened North American skies, with flocks so dense they could block out the sun for hours. Their name came from their constant passage in enormous migratory flocks. This incredible abundance proved to be their downfall. Mass hunting for food and commercial trade, combined with systematic destruction of their forest breeding grounds, drove passenger pigeons to extinction at record speed. The last wild bird was shot in 1901, and the last captive specimen, a female named Martha, died at the Cincinnati Zoo in 1914. Over a century later, scientists at the organization Revive and Restore are working to bring back the passenger pigeon through de-extinction. Their method involves using the band-tailed pigeon, Patagoenus fasciata, a living species that's genetically close to the passenger pigeon. Researchers are sequencing the extinct bird's DNA from museum specimens and comparing it to its modern relative's genome. The goal is to edit the band-tailed pigeon's DNA to introduce passenger pigeon traits, distinctive body size, plumage patterns, reproductive behaviors, social structures, and migratory instincts. If successful, the edited embryo would be placed in a viable egg for incubation, potentially producing a bird that looks and behaves like the original passenger pigeon. Number 2. Giant moa. Moas were giant flightless birds that lived in New Zealand until just about 600 years ago. Some species reached over 10 feet tall and weighed up to 550 pounds, making them among the largest birds ever to exist. With well-preserved skeletons, fossilized eggs, and even soft tissue found in caves and peat bogs, the idea of reviving moas through de-extinction has attracted researchers in New Zealand and worldwide. While ancient DNA has been successfully extracted from some specimens, the path to moa de-extinction faces enormous obstacles. The biggest challenge is the absence of a truly close and compatible living relative. The closest known relatives today are tinamous, small, flying birds native to South America. The difference in body size, embryonic development, and reproductive biology between these modern birds and the giant moa is vast. This makes it extraordinarily difficult to use any modern species as a base for genetic editing and, more critically, as a host for an edited egg. Creating a functional moa embryo, let alone a viable artificial egg large enough to support its development, represents technological hurdles not yet overcome. Number 1. Ground sloth. Completing our list is Smileodon, one of the best-known ground sloths from prehistoric times. Though smaller than its more famous relative Megatherium, Smileodon darwini was still an impressive animal, measuring around 10 feet long and weighing several hundred pounds. These giant herbivores inhabited South America until roughly 10,000 years ago, likely disappearing due to a combination of climate change and human hunting. What makes Smileodon a potential de-extinction candidate is the remarkable preservation of some of its remains. In 1895, a cave in southern Chile yielded furry hides, soft tissues, and even fossilized dung, an extraordinarily rare find that enabled the extraction of ancient DNA in surprisingly good condition. With this material, scientists have sequenced significant portions of the genome, placing Smileodon among the names frequently mentioned in de-extinction discussions. Are you seeing this video that is appearing on the screen? Click on it because I have set it aside especially for you to watch. If you liked this video, I'm sure you'll like our recommendation. Well, that's it, and until next time, Curious One.